Welcome to Module 5. In this session, we will move from theory into practice. You will explore case studies and exercises designed to help you apply the systematic storytelling presentation step by step. Before diving into case studies, remember the core framework. Identify the knowledge dimension first, then decide the cognitive process level. Together, they form your learning objectives, which guide the story. In aviation security, one case study is handheld metal detectors or walk-through metal detectors. Remember, the more concrete, the more easier knowledge dimension is explained. The knowledge is factual, conceptual, and procedural, about the tools. We must break down the handheld metal detectors or walk-through metal detectors into part of knowledge dimensions, the factual knowledge, the conceptual knowledge, and the procedural knowledge. Then define the cognitive process dimension. As in case studies, we define the ability cognitive into level applying, breaking down how handheld metal detectors or walk-through metal detectors worked. In business, imagine analyzing customer feedback from surveys. The knowledge is factual, the survey data. The cognitive tasks are to evaluate the insights and create a new strategy for customer engagement. So, do you understand so far? Your first exercise: choose one tool from your own profession. Identify its knowledge type: factual, conceptual, procedural, or metacognitive. Then, decide which cognitive level learners must reach with that tool. The second exercise is to write learning objectives. Use the formula, verb from the cognitive dimension plus the tool as knowledge. For example, student will be able to operate a handheld metal detectors. The third exercise: create a mini-story. Think of a situation where your learners face a real challenge. Use storytelling to bring the objective alive, guiding them step by step through the process using the framework above. To begin this exercise, we start from the very first layer of the knowledge dimension, factual knowledge. This type of knowledge answers the question, what is it? It includes terminology, parts, codes, or basic details that professionals must know before they can move forward. Let's take an example. Imagine we are talking about an aviation security officer. Their daily work involves specific standardized tools. One of the most common is the handheld metal detector, or HHMD. At the factual level, what the officer must first know is, what is an HHMD? What does it look like? What parts does it have? And what are its basic functions? Once learners understand the factual elements, the names, parts, or terms, the next step is to move into conceptual knowledge. Conceptual knowledge explains how those elements are organized and how they work together. At the conceptual level, the officer needs to know not just the names of its parts, but how those parts interact to detect metal. For example, the scanning head emits signals, the circuitry processes them, and the alert system, light or sound, warns the officer when metal is detected. The concept here is how the HHMD as a system works through the interaction of its components. Conceptual knowledge is about interconnection and structure. It answers the question, how do these elements fit together to form meaning or to make the tool function properly? Without conceptual understanding, learners only know pieces, but cannot see the whole picture. After learners know what the tool is and how its parts work together, the next step is procedural knowledge. This level of knowledge explains how to use the tool correctly following standardized steps or protocols. For the aviation security officer with the handheld metal detector, HHMD, procedural knowledge means knowing the exact sequence of scanning passengers. 1. Position the device at the correct distance. 2. Move it systematically from head to toe, without skipping body areas. 3. Respond appropriately if the alarm is triggered. Each of these steps is written in a standard operating procedure, SOP, that must be followed consistently to ensure security and fairness. Procedural knowledge answers the question, what steps must I follow to make the tool or system work properly according to standards? It transforms knowing and understanding into doing. Without procedures, the knowledge remains theoretical and cannot be applied in practice. With these techniques, you can expand more slide in the beginning.